Okay, so in the last video I showed you how to find the sum of a series, and so now we're just going to look at some examples, and you're going to determine whether they are sequences or series, finite or infinite, and whether they're algebraic or geometric. So your first one you're going to be doing is 4, 7, 10, 13, 16, and 19. So take just a minute. I'm going to go ahead and write a couple of these down. Okay, so let's look first at the first one. And is it a sequence or a series? Again, the series is the sum of, and that is not a sum of. So this one is a sequence. Is it finite or infinite? Well, it doesn't have the continuation dots, so it is finite. And then the question is it algebraic or geometric? So the question is, do I add to get to the next term, or do I need to multiply? And in this case, when I look at it, I add 3, add 3, add 3. So that means that it is an arithmetic, because it has a common difference. Okay? The next one. Again, it does not have the addition symbols in there. It is a sequence. It does not have dot, dot, dots, so it is also finite. And then when you look at it, and you're looking to see what we need to do to get from one to the other, first off, you could say, well, I could add 4, or I could multiply by 2. Either one, but when I go to the next one, in order to get from 8 to 16, I can't add 4, so that eliminates it being arithmetic. But if I do times it by 2, it's going to work, and now I see that that is my pattern. Okay, so it is a geometric. And we come back in and do geometric when we are talking about exponential functions. Okay, so that's actually second semester when we come back in and do that. Okay, the next one, again, you see that addition sign in there, so that does make it a series on there. And then you have, again, the dot, dot, dots, so that would be an infinite. And then when you look at how to get from 5 to 9, you could add 4. That also works to get to 13 to 17. So we're adding 4, so it is arithmetic. Okay, and then the last one, again, it has the additions in there, so it is a series. It does have the dot, dot, dots on there, so it would be an infinite one. And then to get from 3 to 12, I could add 9, but that doesn't work to get to 48. So I could multiply by 4, and then that would work, and so it's going to make it a geometric